I want to continue with BJT construction and operation. This is a proper biasing for PNP and NPN transistor. The first one is for PNP and the second one is for NPN. As you can see here, you can see the biasing with DC supply VEE and VCC supply are connected to E, B, and C. And also with the NPN transistor, you can see the connection is actually different from the PNP. For the PNP, E is connected to the positive and B connected to the negative. However, for the NPN, the E terminal is connected with the negative and B is connected with the positive. Okay, why this transistor connect with the different terminal of the DC supply? I will explain later in the next slide. This proper biasing is for transistor operation in active region. What is active region? Okay, you should remember this one. This is for PNP and this is for NPN. I will explain the operation of the transistor. Examine the PNP transistor for its forward bias junction at terminal E to B. In this figure, you see the terminal E is connected to the positive VEE and the terminal B is connected to negative VEE. This one, it is very similar to a forward bias diode. The majority carrier holes flow from E to B, and then the minority carrier electron flows from B to E. It will resulting in small depletion region here. As you can see, the black line here, this is small depletion region. This means that the current flow heavily from E to B. So this is actually a forward bias condition is achieved where P has majority of holes as a carrier. The holes has been pushed by the positive VEE, while at the B terminal there is a negative here, so it will attract the positive or the holes go through from E to B. That's why we get the majority carriers flow from E to B. So this is actually the condition of the forward bias. It is similar as you learn from the diode. Next, we see at another side of the transistor, we examine its reverse bias junction at terminal B to C. It is very similar to a reverse bias diode. Only minority carrier holes flow from B to C. There are no majority carrier flows, and then resulting in big depletion region. This means that the current flows lightly from E to B. So take a look here. This is the positive VCC connected to the B. So, and then you can see the C now connected to the negative terminal. So majority of the holes, majority carrier of the P material will attracted to the negative, and then the positive here will push holes minority inside the N, and then we go through to this side. However, it will resulting a large or a very wide depletion region. So this is a reverse bias. That's why you see the first one here for the E and B, this is a forward bias. And for the right side, this is a reverse bias condition. So what happened with the NPN? For the NPN, this is forward bias and this is reverse bias. You should check it later and compare the operation for the PNP and NPN. Just remember the condition of the forward bias and the condition of the reverse bias.